sequence is always infinite. Is always infinite, but range may be finite or infinite. Okay, range may be finite or infinite. What is the meaning of constant sequence? Constant sequence means every term of a const every term of a sequence is a constant. Then we call that sequence is a constant. Example, xn. Okay, xn is a sequence now such that xn equal to c, where c belonging to r. Okay, for every n belonging to natural number. Means if we write the terms of the sequence will be c c c infinite number of times. Okay, means x1 is c, x2 is c, x3 is c. Okay, so this is a constant sequence. Okay, now we write bounded above sequence. Bounded above sequence. Bounded above sequence, the definition is a sequence an is a sequence is bounded above if there exists a real number k such that an less than equal to k for every n belonging to natural number. What is the meaning of this? Meaning of this is the range of a sequence is bounded above. Okay, range means number of distinct term of the sequence. This is the bounded above sequence. So now, for example, if I am writing, this is the sequence. Okay, so number of terms in this sequence will be -1, -4, -9. These are the number of terms. Here, if we see this definition, a sequence an is bounded above if there exists a real number k such that all the terms of the sequence less than or equal to k for every n belonging to natural number. So here we see that k value is -1. Okay, here k value, because all the, if I am taking an equal to this is the sequence. So here k value is -1 means that all the terms of this sequence is less than or equal to -1 for every n belonging to natural number. Okay, so -1 is the bounded above element. Okay, so bounded above element means -1. Bounded above is equal to -1. Similarly, we write bounded below sequence. Bounded below sequence. wait, wait 2 minutes. Yes. So now bounded below sequence. So bounded below sequence means same definition you apply, but here the difference: a sequence an is bounded below if there exists a real number k such that an is greater than equal to k. Okay. If all the elements of the sequence is greater than equal to k, then that sequence is called as the bounded below sequence. Okay, bounded below sequence. For example, if I am writing this sequence, factorial n. Okay, this is the sequence. Now here if we write the terms, so 1, 2, 6, in this way terms will come. So here if you see all the elements of this sequence, here an is equal to factorial n. Here an is greater than equal to 1. All the terms of the sequence is greater than equal to 1 for every n belonging to this natural number. So here bounded below element is 1. Okay, bounded below element is 1. Now this is bounded below and now bounded sequence, which is bounded above, bounded below as well as bounded above. The sequence which is bounded below as well as bounded above is called bounded sequence. bounded sequence. We are this is a sequence.
So please show the previous slide.
Yes. Okay. Now, suppose if we are taking this, so number of terms here minus 1, 1, minus 1, 1. These terms are there. Here bounded below element also you have. Bounded above element also you have. Okay. Bounded above element is 1. Bounded below element is minus 1. Okay. So this is a bounded sequence. Bounded sequence. Now unbounded sequence. Unbounded sequence. Which means the sequence is either bounded below, means only bounded below, bounded element above element does not exist, or bounded above means bounded below does not exist, or none. Okay, means neither bounded below nor bounded above. Sequence is called as unbounded sequence. It's called as unbounded sequence. Unbounded if we are writing sequence 2 to the power n, here the terms are 2, 4, 8. Okay, these are the terms. Here 2 is the bounded below element. Bounded above element you cannot. This is bounded below element. You cannot find out bounded above element here. Okay. So this is unbounded sequence. Unbounded sequence. If I am giving this is a sequence minus 3 to the power n. Okay. Here this is neither bounded below, neither bounded above. Okay. So here you cannot find out bounded below element. Okay. And bounded above element also. Okay. So this is unbounded sequence. Unbounded sequence. Okay. The sequence is minus 1 to the power n on n. Okay. Sequence is bounded or unbounded? If bounded, then what is the bounded element and what is the bounded below? Anyone?
They're bounded.
So what is bounded here? What is bounded below? Because if this is bounded means you can find out bounded above element also, bounded below element also.
Yes, sir. Bounded below -1.
Below -1, okay, and bounded above
1/2.
1/2.
1 by 2. Because when you find out the value, the terms of the sequence, you will get -1, 1/2, -1/3, 1/4. Similarly, at the 0. Here, if you see bounded above element, which is 1/2, means all the terms are less than equal to 1/2. So this is bounded above element, and bounded below element is -1. So this is bounded sequence. Next example is, suppose I am giving this sequence. Tell me, this is bounded or not? Bounded? Bounded below element.
Yes, sir, it is bounded.
Yes, sir. Bounded below by 1/2 and bounded above by 1.
So this is bounded sequence, because here the terms are 1/2, 2/3, 3/4, and at the end 1. So bounded is bounded below element,
Bounded, sir.
bounded below, and this is bounded above. Bounded above element. So this sequence is bounded sequence. Okay. 5/3. This is 3.
Yes, sir, they're bounded, sir.
Both are bounded, sir.
Bounded here. And what is the bounded below?
Sir, bounded below is -1 and bounded above is 1.
Below is above is 1.
Yes, sir, bounded above is 1.
Actually, what is the thing that bounded above element and bounded below element? This is not unique also. Okay. Because we know the sine and cos function is always bounded by -1 and 1. So that is also the bounded below and bounded above element for sine cos term. But if you see the range set, okay, if you find out the terms of the sequence, then here under root 3/2, 3/2, 0, again -3/2. So if you see in the range set bounded below element, then bounded below is minus root 3/2. Okay, and bounded above is root 3/2. Okay, that is also bounded below element. Okay, and because this is not unique. Okay, it is not compulsory that. But if you see the means least upper bound, the concept of least upper bound means one is also the upper bound means bounded above element. So what is the least term of this? Okay, that we can say this is a least term. Okay, and greatest lower bound. This is the greatest lower bound. Okay, least upper bound and greatest lower bound. So that is the different concept. But here this is bounded and this is also bounded. That least upper bound, greatest upper bound also we will see in the coming classes. But here the concept is this and this both are bounded sequence. Bounded sequence. Okay.
Sir,
Office sequence.
sir,
Yes.
sir, in the last slide, sin n3 pi is should also be bounded between -1 to 1, no? Or bounded below -1 and bounded above 1. I'm not able to
Yeah,
understand.
that is also means -1 also bounded below element and but if you see the range set in the range set that -1 and 1 will not come.
Therefore,
Okay, if you find out sin pi by 3 root 3 by 2 sin 2 pi by 3 sin 3 pi by 3 means sin pi is 0. So if you find out the range set, so range set always root 3 by 2 0 and minus root pi by 3. Okay.
okay, sir.
Yeah, but if you say that bounded below element is -1, that is also right. Okay, because this is not unique. Bounded above element and bounded below element is not unique, and it is not compulsory that exists in the range set also. Okay, it may exist, it may not exist. But if you see the range set of this, then -1 and 1 will not come. Now monotonicity. Monotonicity of a sequence. Now here is first is increasing sequence. Increasing sequence. Increasing sequence means let xn be a sequence such that xn plus 1 is greater than equal to xn for every n belonging to n. This is called as increasing sequence. Okay, means terms are increasing. For example, if I am writing 1, 2, 2, 3, 3, 3, 4, 4, 4, 4. Okay, this is a sequence. Here, either the next term is greater than or equal to. So this is a increasing sequence. So next one is strictly increasing. Strictly increasing sequence.
Sir,
In
then the
strictly
constant
increasing,
sequence is also increasing.
constant sequence. No, neither increasing nor decreasing. That is a constant sequence only. Okay, we cannot say either means that is
Sir, but that sequence also follows the rule xn plus 1 is greater or equal to xn.
But that also for the decreasing sequence rule also that is following, means xn plus 1 less than equal to xn.
We can say that it is increasing also and decreasing also.
In that case, what you can say? Decreasing sequence also. Decreasing, because decreasing definition is xn plus 1 less than equal to xn. So that is both increasing or decreasing, both you can say. Okay. Decreasing means suppose xn is a sequence such that xn plus 1 is greater than xn for every n belonging to n. Okay. For example, this is a sequence which is a increasing sequence. Okay. Similarly, decreasing sequence.
Sir, can you please show the previous slide?
Yes.
Thank you, sir.
Similarly, decreasing sequence. Decreasing sequence means suppose xn be a sequence such that xn plus 1 less than equal to xn for every n belonging to natural number, then this sequence is a decreasing sequence. Similarly, strictly decreasing also. Strictly decreasing sequence means strictly n plus 1 is xn for every n belonging to, and this is the strictly decreasing. Yes. Now you have to check. This is the sequence I am giving. 2n minus 7 n plus 2. This is a sequence. This for to check this.
Sir, you are not audible.
Yes, 1 minute.
Yes, sir, your voice is breaking.
Hello. Yes. Now audible.
Yes, sir, strictly increasing, sir.
Strictly increasing. Yes. How to calculate this? What is the way to? This is a strictly increasing sequence. Yes. Yes. Here, let this is the xn sequence. Okay, which is 2n minus 7 upon 3n plus 2 means xn value is 2n minus 7 upon 3n plus 2. So what is the value of xn plus 1? Put n plus 1 in place of n. So 3n plus 1 plus 2. So this will come 2n minus 5 and 3n plus 5. Okay. Now you calculate xn plus 1 minus xn. Okay. So after subtracting this, you will get 25 upon 3n plus 5 into 3n plus 2. Now here you can see for all values of n, this is always greater than 0. Okay, this is greater than 0 for every n belonging to this natural number. Okay, so you can write xn plus 1 minus xn greater than 0 means xn plus 1 is greater than this. So this is strictly increasing sequence. So there are two ways to show that the given sequence is strictly increasing or decreasing or increasing by subtracting two successive terms or by dividing. By dividing means xn plus 1 you can find out, then divided by xn, then you have to show that is greater than 0 or less than 0. Okay, so both the way you can apply and you can show the given sequences increasing or decreasing. Okay, so this is strictly increasing sequence. Now the sequence an where a is greater than 0. Now tell me, this is increasing sequence or decreasing sequence?
Sir, if A is between 0 to 1, it is decreasing sequence. If A is greater than 1, then it is increasing sequence.
Okay, and if a equal to 1, then this is a constant sequence.
Yes, sir.
Okay, so here how to prove? You can write xn plus 1 from n. Okay, that value will come a. Value will come a. So if a is less than 1, okay, if a is less than 1, it means xn plus 1 upon xn is less than 1, means xn plus 1 less than xn. Okay, so this is strictly decreasing. Similarly, if a is greater than 1, then strictly decreasing, and if a equal to 1, then this is a constant sequence. Okay, and if this, then strictly increasing sequence. Okay, so in this way, by dividing xn plus 1 or xn upon xn plus, you can is what is convergent.
Hello, sir.
Yes,
Sir, your voice is breaking continuously.
yes. Now here our hello. Yes, again I connected. Yes. So now concept of convergent sequence. What is convergent sequence? Convergent sequence definition is a sequence an is said to be convergent, if limit n tending to infinity an is finite and unique. If the limit of the sequence, okay, is finite and unique, that is convergent. For example, if I am giving, this is a sequence 1 of the power n, okay, 1 upon 2 to the power n, Then here you find out, here an value is 1 upon 2 to the power n. So you can find out the limit. So when you find out the limit, that value is 0. And 0 is finite and unique. So this is a convergent sequence. Okay, this is a sequence. Now divergent sequence. Divergent sequence. Divergent sequence is sequence an is said to be divergent if limit n tending to infinity an is not finite. Okay, not finite means either you are getting infinite or minus infinite. Then that sequence is divergent sequence. For example,
Sir, please previous slide.
yes.
Thank you, sir.
Okay. If I am taking this sequence, so here in this sequence, if I am taking the limit of this, we are getting infinite value. Or if I am taking this sequence, okay, then here we are getting minus infinite. So both the sequence are divergent sequence. Okay, because we are getting not finite value, either infinite or minus infinite. Okay, now next oscillatory sequence. Oscillatory sequence. Now if a sequence an neither converges to a finite number nor diverges to plus infinity or minus infinity, then it is called oscillatory sequence. And there are two types of oscillatory sequence.
Sir, please show the previous slide.
Yes, 1 minute.
Sir, that means limit n tends to infinity does not equal to 0 and infinity, no?
No. Zero here, 0 is coming. Okay, 0 is coming means convergent sequence does not meaning this is 0. This may be 1, this may be 2, this may be 1 by 2, 1 by 4, any value, but finite value and unique value also. Okay, but if we are getting finite value but not unique, for example, minus 1 to the power n, when n is odd, and minus 1 and is even then 1, you are getting finite value but not unique. That means that is oscillatory sequence. Okay, so oscillatory sequence, two types. Finitely and oscillate infinitely. Oscillate infinitely. Okay. So, for example, if I am taking this is 1 power n, this is a sequence. If we write the limit of this then you will get 1 when n even and -1 when n odd. Okay, so this is oscillatory sequence because we are getting finite value but not unique. So this is oscillatory. And if we write the sequence minus the power n in n, this is a sequence. Okay, and if you find out the limit of this sequence,
Sir,
yes,
-1 to the power of infinity is undefined, no? How can we say it is even or odd? Or n even or odd or 1 or -1?
no, -1 to the power n, this is when n even, then this is 1. When odd, then this is
So, sir, infinity cannot be even and
1
odd.
to the power infinite, I am not writing. Okay, here -1 to the power n. There is a difference that 1 to the power infinity is indeterminate form, -1 to the power n, this is not the indeterminate form. Okay, here for this we can write the limit. This depends on n even or odd. Okay, because the infinite term we cannot say that the infinite term is even or infinite term is odd. That's why when n even, then -1. And here if you write the limit of this, then this is plus infinity, then n even, and this is when n odd. So here also the limit in divergent sequence we are getting a limit that is infinite or minus infinite, but only one value. Okay, but here infinite, positive infinite and negative infinite, both the values depending on the conditions we are getting. So this is the oscillatory sequence. Okay, so this is also oscillatory sequence which oscillate infinitely. This is a also oscillatory sequence but oscillate finitely. 1 and -1. As you study in the physics also, if I am writing this is a lens here, and these are converging at a unique point. Fine. So that's why we are called as this is a converging lens. Converging lens. And if we take this lens, here rays will come, then this. Okay, that's why this called is diverging lens. Diverging lens. Okay. So here the concept of oscillatory and divergent and definition. Okay, after this it will be limit of a sequence that we will see in the next class. Limit of a sequence. Okay, that we will see in the next class. Okay, and tomorrow I will give submission of fourth assignment, and because the syllabus of this not sufficiently, so this week tutorial will not be there because now tutorial of sequence series will come with assignment. So after completion of some syllabus in this week, in the next week tutorial of sequence series will start. Okay, this week tutorial of this and tutorial class will not be. Uh, yeah, the coming Saturday means 12 of February. Your first quiz will be there of 10 marks, having syllabus first and second unit completely. Volume also coming, beta gamma also coming, Leibniz also coming, surface area also coming. Means complete second unit and first unit. Okay, both the unit completely for the quiz. So quiz will be on the Saturday. The timing I will tell later. So accordingly, be prepared.
Sir, for how much time, sir?
And same answer book, some books, the seats are remaining. So if I completed today evening, then I will take your query in the evening. Okay, if I will not complete, then I will take tomorrow. Okay, I will
Sir,
send. You have your answer sheet PDF copy. Okay, I will send the solution sheet and step by marking also on that solution sheet. Okay, so accordingly you can see where you did mistake and how many marks you are getting. Okay, I will not show your answer sheet. I will tell you only the marks what you obtained in the midsem. Okay, but if you uh, my marks is less, then you can ask. I will tell where you did mistake, but I will not show your answer sheet. So your answer sheet is with you, and I will give the solution with the step-by marking. So accordingly, you can tally your marks. Okay. So if I am able to complete in the sorry,
sir,
sorry, tomorrow.
how much time will be given for the quiz, sir? 1 hour?
For the quiz, not 1 hour, minutes or 30 minutes only. Because objective questions,
Sir, how many questions are there, sir?
10 questions, small are there. So maybe 30 minutes. So 30 minutes, 10 marks, objective answer. Okay, only. So and rough work, whatever the rough work you did, that maybe also have to upload. Okay. So that is today. Video I will see. Okay, thank you. What? And Sam. No, this quiz syllabus is first unit and second unit. Quiz 1 syllabus. Quiz 2 will be on the 26th of February. And the syllabus for this sequence series means only unit 3rd. Okay, and in MSAM, whole syllabus will come. But the maximum question from 3rd and 4th unit, but from first unit and second unit also the question will come. Okay, and send the complete syllabus. Yeah, thank you.